Hi, and today we are going to work on the problems which are based on the matrices and determinants. But before starting this exercise, I suggest you to be very clear with your fundamentals because we are not going to discuss any of the fundamentals in this tutorial. And we are going to discuss about matrix and determinants. Okay, so here's our first example, and if x is the matrix which has 4 rows and 3 columns, and y is the matrix which has 4 rows and 3 columns, and if the p is the matrix that has 2 rows and 3 columns, then find the order of this term where the t represents the transpose. So what we are going to do is we are going to write this as 2 rows 3 columns of p multiplied by x transpose, means the rows get transformed into columns and column will get transformed into rows. So this will be 3 by 4 and y is of 4 by 3, and we need to take the transpose of this, and p transpose is 3 by 2 matrix, and we need to take the transpose of this whole term. So what we are going to do is, here we have another bracket, so here we have 2 by 3 matrix and the columns of the matrix x transpose is equal to the rows of y. So we can multiply this and our resultant will be 3 over 3 by 3 matrix, and when we take the transpose of the 3 by 3 matrix, it will be again 3 by 3 matrix, and this is multiplied by 3 by 2 matrix, and we are going to take the transpose of this whole term. Now we can multiply this matrix with either of this or this, because the matrix multiplication is associative. Matrix multiplication is associative. So we'll multiply this matrix with this matrix. So these are row, column. The column will match with the row of this matrix. So here we have the result will be 2 over 3 times 3 by 2 matrix, and we are going to take the transpose, and if we multiply these two matrix we'll get 2 by 2 matrix transpose, and the transpose of the 2 by 2 matrix is 2 by 2. So the order of this term is 2 by 2. Let's take another example. So if A has m rows and m plus 5 columns, and B has n rows and 11 minus n columns, if A, B and B exist, then find the order of A and B. So in this case they have clearly mentioned that A has m rows and m plus 5 columns, and B has n rows and 11 minus n columns. So if we multiply AB, then this is the row, this is our column, this is row, this is column. The column of matrix A should match with the row of matrix B when we multiply AB. So m plus 5 should be equal to n, and they have mentioned that BA also exists. So B has n rows and 11 minus n columns, and A has m rows and m plus 5 columns. So when we multiply BA, then this is row, this is column, this is row, this is column, then the column of the matrix B should match with the rows of matrix A. So 11 minus n should be equal to m. So let's say this is our equation number 1, this is our equation number 2. If we put the equation number 2 in equation number 1, we get 11 minus n plus 5 is equal to n. So 16 is equal to 2n and n is equal to 8. So if n is equal to 8, then 11 minus 8 is equal to m, and 8, 9, 10, 11, so m is equal to 3, and they have asked us to find the order of A and B. So the order of A will be equal to M is 3, and the column of matrix A will be equal to 5 plus 3, which is 8, and B has n rows, so this is 8, and 11 minus n, that is 11 minus n is 3, so this will be 8 by 3 matrix. So let's take another example. So here's our question. If A is Aij, which has 3 rows and 4 columns, such that Aij is equal to I plus j for all ij, find the sum of all elements of A. And here what we are gonna do is, here Aij is 3 by 4 matrix, so A is equal to, these are 3 rows and these are 4 columns, and Aij is equal to I plus j, so this is first or first element, first or second element, first or third element, first or fourth element, and this is second or first element, second or second element, second or third element, second or fourth element. This is third or first element, third or second element, third or third element, and third or fourth element. And Ij is equal to I plus j, so this is gonna be equal to 1 plus 1, 1 plus 2, 1 plus 3, 1 plus 4, this is 2 plus 1, 2 plus 2, 2 plus 3, 2 plus 4, this is 3 plus 1, 3 plus 2, 3 plus 3, and 3 plus 4. Now we can split this matrix into the following way, and what we are gonna do is, we are gonna split this matrix, so we can write 1 2 3, 1 2 3, 1 2 3, 1 2 3, and plus we are gonna write 1 2 3 4, 1 2 3 4, 1 2 3 4. Okay, we can split this matrix like this. We can write 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, and 1 plus 4 is 5. So these are one and the same. So what we can do is, we know that 1 plus 2 plus 3 is 4 times, 1 2 3 4, 4 times, plus this is 1 2 3 4, 1 plus 2 plus 3 plus 4, this is 3 times. So let me take out my calculator, and we know that 1 plus 2 plus 3 is 4 times, and 1 plus 2 plus 3 plus 4 is 3 times, so this is 54. So the sum of all the elements of A we can find from this matrix, that is, if we do, so here we have 2 plus 3 plus 4 plus 5 plus 3 plus 4 plus 5 plus 6 plus 4 plus 5 plus 6 plus 7, and this is equal to 54. But what when the matrix has large number of rows and the large number of columns? So in this case it is inconvenient, or we can say as time taking method. So if we closely look at this matrix, this is 3 by 4. So what we can do is, here, okay, so we can split this matrix into, if we know the general expression that the sum of n natural numbers is given as n times n plus 1 by 2. So if we closely look that, so this is 3 by 4 matrix, so if we write as 3 times 3 plus 1 by 2 multiplied by the columns, plus 4 times 4 plus 1 by 2 multiplied by the rows, so this is exactly, this should be exactly equal to 54. So let's see, 1 into 3 plus 1 by 2 multiplied by the columns, plus 4 multiplied by 4 plus 1 by 2 multiplied by the rows, and this is exactly equal to 54. So let's say see another example which has 10 rows and 11 columns. So in this case, if we approach this method, then this is gonna take very long time. So if we make the use of sum of natural numbers, so we know that these are our rows, these are our columns. So 10 into 10 plus 1 by 2 multiplied by the columns, plus 11 multiplied by 11 plus 1 by 2 multiplied by the rows. So this should be equal to 10 multiplied by 10 plus 1 by 2 multiplied by 11 plus 11 multiplied by 11 plus 1 by 2 multiplied by 10. So the sum of all elements of A is equal to 1265, and if we calculate this value by making this process useful, then it will take very long time, because we need to split this matrix into two matrices and we need to follow this process, then it will take much time. So this is the shortcut method to find the sum of all the elements of any matrix A. So let's take another example. So here we have our next question. So if A is the matrix Aij which has 2 rows and 3 columns, and B is the matrix Bij which has 3 rows and 4 columns, how many additions and multiplications are required for the product AB? So if A is the matrix which has 2 rows and 3 columns, and B is the matrix which has 3 rows and 4 columns, so this is first row first element, first row second element, first row third element, and this is second row first element, second row second element, and second row third element. And here we have B, first row first element, first row second element, first row third element, first row fourth element, second row first element, second row second element, second row third element, second row fourth element, third row first element, third row second element, third row third element, and third row fourth element. So this is 2 by 3 matrix and this is 3 by 4 matrix. So here the columns of A will match with the rows of B. So we can multiply this matrix, and the resultant AB matrix will be of 2 by 4 matrix, because here we have 2 rows and here we have 4 columns, and the columns of the matrix A are matching with the rows of matrix B. So if we multiply this matrix, we'll get A11 multiplied by B11 plus A12 multiplied by B21 plus A13 multiplied by B31. So this will be again 2 rows and 4 columns. So these are 1, 2, 3, 4, and this should be 1, 2, 3, 4. So the number of multiplications, in this case will be equal to these are 1 multiplication, 2 multiplication, 3 multiplication. So 3 ones are 3, 3 twos are 6, 3 twos are 9, 3 fours are 12, 12 twos are 24. So we have to do 24 number of multiplications to obtain matrix AB, and number of additions are, here we have 1 addition, 2 addition, so 2, 4, 6, 8, 8 times 2 is 16. So 16 number of additions we need to do to find the matrix AB. But this process is useful when the matrix has less number of rows and columns. But what if the matrix has large number of rows and large number of columns? Then in this case, if we closely look at this matrix, so number of additions are equal to, if we name this is m, this is n, this is n, and let's say this is our p. So number of additions should be equal to m p times n minus 1, and number of multiplications should be equal to m p n. Let's check in this example whether it matches with the final answer. So m here is 2 into p is 4 and n is 3 minus 1. So number of additions are 16. Okay, 16 is the right answer. And the number of multiplications are m multiplied by n multiplied by p is 4, so this is 24. So let's do this exercise in our next example, which has m rows and n columns, and this has n rows and p columns. So in this case, if A is the matrix which has Aij, which has m rows and n columns, and B is the matrix which has n rows and p columns, then how many additions or multiplications are required in the product AB? So we know that number of additions is equal to m times p times n minus 1, and number of multiplications is equal to mpn. So this was a shortcut technique how to find the number of additions and number of multiplications of the matrix which has large number of rows and large number of columns. So let's take another example. So our next example is little bit complicated, but we can make the use of the technique and we can solve this example. So if A is the matrix which has 3 rows and 4 columns, and B is the matrix which has 4 rows and 5 columns, and if C is the matrix which has 5 rows and 3 columns, find the minimum number of addition and multiplication required for product ABC. If we know here the exact number of addition and multiplication is not possible, because matrix multiplication is associative, means that is we can multiply the matrix AB with matrix C, and we can multiply matrix A with matrix BC. So in this case the exact number of multiplications and the exact number of additions are not possible. So first what we'll do is we'll multiply BC. So matrix B has 4 rows and 5 columns, and matrix C has 5 rows and 3 columns. So number of addition will be equal to, this will be our m, this will be our n, this is our n, and this is our p. So number of additions is equal to m multiplied by p multiplied by n minus 1. So this will be 48, and number of multiplications will be equal to m and p. So this will be m, this will be n, this will be p. So this is 60, and now multiplying this matrix A with matrix BC. So matrix A has 3 rows and 4 columns, and matrix BC will have 4 rows and 3 columns, because this is 4 and this is 3. The columns of matrix B are matching with the rows of matrix C. So we multiplied this matrix BC, and our result should be the rows of matrix B and the columns of matrix C. So what we are going to do is, in this case, number of additions will be equal to, this is m, this is n, this is n, and this is p. So number of additions will be equal to m into p into n minus 1. So this will be 27, and number of multiplications will be equal to m into n into p. This will be 36. So total number of additions in multiplying the matrix A with matrix BC is addition is 48 plus 27, so these are 75, and total number of multiplication in multiplying matrix A with the matrix BC is 60 plus 36. So this is 60 plus 36. So this is 96. And now what we are gonna do is, in this case we'll find now if we multiply matrix AB, so matrix A has 3 rows and 4 columns, and matrix B has 4 rows and 5 columns. So this is our M, this is N, this is N, and this is P. So number of additions will be equal to MP n minus 1. So this is M into P is 5 into n minus 1 is 4 minus 1 is 45, and number of multiplications will be equal to M and P. So this will be M, N is 4 and P is 5, so this will be 60. Now we'll multiply this matrix AB with matrix C. So multiplying matrix AB with matrix C. So here AB has 3 rows and 5 columns, and matrix C has 5 rows and 3 columns. So in this case the number of multiplications will be equal to M and P. This is M, N, N and P. So number of multiplications will be M into N into P, that is 45, and number of additions will be equal to M into P into N minus 1. This will be equal to 36. So we know that total number of addition in adding the matrix AB with matrix C is equal to 45 plus 36. So this will be 45 plus 36. This will be 81, and the total number of multiplications in multiplying the matrix AB with matrix C will be equal to 60 plus 45, and this is 105. But here they have asked for the minimum number of additions and multiplications required. So from these two conditions we know that the minimum number of additions required, so from these two conditions the minimum number of additions, here we have 75 and here we have 81. So the minimum number of additions are 75, and the minimum number of multiplications will be equal to, here we have 96 multiplications and here we have 105. So this is 96. And now if we are interested in calculating the maximum number of additions and multiplications required, so the maximum number of addition will be equal to here we have 75 additions and here we have 81, so maximum is 81, and the maximum number of multiplications required, here we have multiplications 96 and here we have 105. So the maximum number of multiplications here will be 1, not 5. Let's take another example which is dependent upon how to find the trace of a matrix. So here we have a question. The trace of the matrix, find the trace of the following matrix. So we know that the trace of the following matrix, so the trace of matrix is equal to the sum of all principal diagonal elements. So here this is called a principal diagonal element and not this. This is not called, this is not our principal diagonal element. Our principal diagonal is this. So the elements of the principal diagonal will be 1, -1 and 6. But the trace of the matrix is sum of all these elements. So 1 plus -1 plus 6, which will be equal to 1 minus 1 plus 6, which will be equal to 6. So the trace of this matrix is 6. And our next example is dependent on how to find the determinant. Okay, here we have the determinant, so we are not going to represent this in the matrix form. So we can find the determinant by usual method as we find the determinant of the 3 by 3 matrix, but here we have 4 rows, 1 2 3 4, and 4 columns, 1 2 3 4, and if we multiply by taking 1 and the cofactor of these, then it will take a very long time. So here we have a shortcut process. What we can do is, if we make the 3 elements, so here what we want to do is, in order to reduce our time to find the determinant, we need to make 3 elements from the given determinant equal to 0. So let's try this by making these elements equal to 0, because here we have already 1 0, and the shortcut technique for solving this determinant is, if we do it like this. So if we take, this is R1, R2, R3 and R4. If R4 in such a way that R4 plus R1, and here we have 2, so if we multiply, so R2 in such a way that R2 minus 2 times R1. So let's check. R4 is -1 plus 1 will be equal to 0. Okay, this is right. And R2 is 2 minus 2 times 1, so this is 2 minus 2, which will be equal to 0. Okay, then this operation is correct. So what we can do is, so 1 0 2 3, and this will be 0, and here we have -1 minus 2 times 0, so this will be equal to -1, and we have 3 minus 2 times 2, so this is 3 minus 4, again we have -1, and here we have 7 minus 2 times 3, so here we have 7 minus 6, so this is +1, and here we have 0 1 3 5, because we are going to operate only 4th row and 2nd row, so 3rd row will be as it is, and here we have 0, and here we have 2, here we have 2, and 5 6 6 7 8 9, so here it should be 9. So we made the 3 elements 0 in the first column, and now what we can do is, if we take this element into cofactor of 1, that is, this is our first row, first element, so here we are gonna take positive sign. So this is 1 multiplied by the cofactor of the matrix. The cofactor of this element is -1 -1 1 1 3 5 and 2 2 9. So now it is very simple to solve this determinant, or else what we can do is, if we can make this elements as 0, then again we can simplify this matrix. So let's try this. So if we take R2 in such a way that R2 plus R1 means 1 plus -1, so this will be 1 -1, which will be 0. Okay, and R3 in such a way that R3 plus 2 times R1 means R3 is 2 plus 2 times -1, so this will be 2 -2, so this will be equal to 0. So let's try this. So this will be 1 multiplied by the determinant -1, -1 and 1. Here we have 0. Here we have 3 plus -1, so this should be 3 minus 1, it's 2. And here we have 6, and this row will be, here we get 0, and here we have R3 means 2 plus 2 times -1, so this will also be equal to 0. And here we have 9 plus 2 times 1, so this will be 9, 10, 11. So again what we can do is we can simplify this. Okay, so we came up with So we came up with 1 multiplied by -1, this is the determinant, -1 and 1, 0 to 6, 0, 0 and 11. So we came up with this determinant, and now we can write that 1 multiplied by this, we are gonna take outside the bracket, so this is -1, and as it is first row and first element, so we are gonna multiply this with the positive sign, so positive negative will be again negative, so this will be multiplied by cofactors of -1, so 1 times -1 into the cofactor of -1 will be, we are just gonna delete this row and this column, so this will be 2, 6, 0, 11. So this will be equal to 1 multiplied by -1, and 11 times 2 is 22, minus 6 times 0 is 0, so this will be -22. So let's take another example. So here we need to find the determinant of this matrix, so we need to find the determinant, so it should be represented only by 2 vertical lines. Okay, so here we already have the 3 elements of the second row, third row and fourth row as 0. So what we can do is A is 2 is first row, third element, so this is, the addition is even, so this will be 1 plus 3, which is equal to 4, so this is plus 2 multiplied by cofactor of 2, so this will be equal to plus 2 into the cofactor of 2 will be equal to, will delete this row and will delete this column. So here we have 3, 1, 4, 0, 0, 2 and 3, 1, 7. And now what we are gonna do is, instead of solving this determinant, it will be easy if we make this 3 as 0. So what we'll do is we'll do an operation, so R3 will be in such a way that R3 minus R1, so this is plus 2 multiplied by 3, 1, 4, 0, 0, 2, and this is 0, 0, and this is 4, this is 7 minus 4, 4, 5, 6, 7, this will be 3. So what now we are gonna do is, okay, so this is positive 2 multiplied by 3 multiplied by cofactor of 3. So this will be 2 multiplied by 3 multiplied by the cofactor of 3 is 0, 2, 0, 3. So this will be 2 multiplied by 3 multiplied by 3 times 0 is 0 minus 2 times 0 is 0. So our answer will be equal to 0. So this was the exercise which was dependent upon the calculation of the determinants and solving some problems on the matrices. We'll meet in the next video with some more problems, and thank you for watching this video.